All right, let's review problem 5 on your MT8 LT5 assignment. We start here, we have this picture of Jermaine and John. They're watching a helicopter hover above the ground. Jermaine and John are standing 10 meters apart. We want to find two expressions that can be used to find h, the height of the helicopter. Well, I'm going to start here with John's triangle. If we take a look at John's triangle, we have this, his angle of elevation is 55 degrees. And we want to use h and x. So opposite adjacent, we're going to say the tangent. So I'm going to say, for the first question, I'm going to say the tangent of 55 degrees equals h over x. And we want to get an expression for h by itself. So I'm going to multiply both sides by x. So in other words, h equals x times the tangent of 55 degrees. Now for Jermaine's triangle, we have the angle of elevation, which is 48 degrees. But notice the distance from the vertical beneath the helicopter to John is x. What's the distance to Jermaine? Well, this total distance, we're going to use the segment addition postulate. And I'm going to say, oh, that total distance is going to be 10 plus x. So now we can use our tangent function again. So this time we're going to say the tangent of 48 degrees equals h, the opposite, over 10 plus x. Or if we want to rewrite that, just solve for h, multiply both sides by 10 plus x. So we have the tangent of 48 degrees times 10 plus x. Now on part B, we want to equate these two expressions and solve for x. Well, since the height doesn't change, they're both equal to h, aren't they? So instead of writing h in the second equation, I'm going to write x times the tangent of 55. So in other words, x times the tangent of 55 equals the tangent of 48 times 10 plus x. Well, let's distribute. So we're going to get x times the tangent of 55 equals 10 times the tangent of 48 plus x times the tangent of 48. Well, at this point, let's move the x's so they're both on the same side. I'm going to change colors here so it doesn't look like one goes to the other. So in other words, x times the tangent of 55 minus x times the tangent of 48 equals 10 times the tangent of 48. Well, let's factor out our x. So we have x times the tangent of 55 minus the tangent of 48 equals 10 times the tangent of 48. Well, then I'm going to do is I'm going to divide both sides by the parentheses to get x by itself. So I'm going to divide both sides by the tangent of 55 minus the tangent of 48. In other words, x equals 10 times the tangent of 48 divided by the tangent of 55 minus the tangent of 48. That's the exact answer. We want to round this to the nearest hundredth. So then we'll use our calculator. So we take 10 times the tangent of 48 I'm going to divide that answer by the tangent of 55. Make sure you close your parentheses. Minus the tangent of 48. Make sure I type that in correctly. Yes. So then x, rounded to the nearest tenth, would be 35.0. Because we round 34.97 up to 35. So x, let me change my equal sign to show that I'm rounding. So is about 35.0 feet. That is not the height. That is the distance, the horizontal distance from John to directly beneath the helicopter. Now, to find how high above the ground the helicopter is, I'm going to replace x. I don't know why I did that. I'm going to replace x with 35. So in other words, and I think it doesn't matter which equation you use. I like this one. H equals x times the tangent of 55, which is really 35 then, times the tangent of 55. So if I use my calculator, I already got my 35 here. So I'm going to take my answer times the tangent of 55 degrees, and I get 49.9, which would be 50 if we round it to the nearest, to the nearest hundredth. Let's back up here. Sorry about that. I didn't read the directions. So the nearest hundredth should be 34.98. Since I just kept all my digits in the calculator, I don't have to rework my calculator. So 34.98 feet is the distance, the horizontal distance from the helicopter to John. So if I take 34.98 times the tangent of 55, I get 49.95 feet. There's all three of the answers for you.